What specific problem does VITA aim to solve in the field of multimodal large language models, and how does it differentiate itself from existing models?
VITA aims to address the lack of open-source multimodal large language models, LLMs, that effectively integrate capabilities across text, vision, and audio, particularly focusing on enhancing user interaction. Unlike existing models that primarily concentrate on image-text modalities, VITA supports a comprehensive range of 4 modalities: video, image, text, and audio, thereby providing a more versatile interaction framework. It introduces innovative features, such as a state token for non-awakening interaction, allowing the model to recognize and respond to audio queries without a wake-up command, and a duplex deployment scheme that enables real-time audio interrupt interaction. Additionally, VITA enhances bilingual proficiency by expanding the vocabulary of the base model to include Chinese, which is a significant improvement over models like Mixtral 8x7b that lack this capability. Overall, VITA's open-source nature and its focus on multimodal understanding and user interaction set it apart from both proprietary and existing open-source models.
How does the proposed method VITA work? Illustrate the entire methodology step by step, including the 3 main phases of training and the rationale behind each step.
The proposed method VITA operates through a comprehensive 3-phase training process: LLM instruction tuning, multimodal alignment, and multimodal instruction tuning. 1. LLM instruction tuning. This phase enhances the Mixtral 8x7b model's bilingual capabilities by expanding its vocabulary from 32,000 to 51,747 tokens, allowing for improved comprehension of both Chinese and English. A synthetic bilingual corpus of 5 million entries is utilized for instruction tuning, ensuring the model can effectively process and generate responses in both languages. 2. Multimodal alignment. In this phase, VITA bridges the representation gap between text and other modalities, video, image, and audio, by training individual encoders and connectors. High-quality multimodal data is collected to align these modalities, enabling the model to understand and process inputs from various sources effectively. 3. Multimodal instruction tuning. The final phase focuses on enhancing the model's instruction-following capabilities across all modalities. This involves integrating audio queries and constructing a diverse dataset that includes both text and audio questions, allowing VITA to recognize and respond to different types of user inputs effectively. Overall, VITA's methodology emphasizes the integration of bilingual capabilities, multimodal understanding, and robust instruction following to facilitate natural human-computer interaction.
Can you provide a detailed example that demonstrates the inner workings of VITA, including how it processes a multimodal input consisting of text and audio?
VITA processes multimodal inputs through a structured pipeline that includes several key components. For instance, when it receives a multimodal input consisting of text and audio, it first identifies the type of input using state tokens. If the audio input is a query state token less than 1 greater than, VITA generates a response based on the audio question, utilizing its audio encoder that processes the audio through a MEL filter bank and transformer layers, converting it into tokens. Simultaneously, if the input includes text, VITA employs its extended vocabulary, which has been enhanced for bilingual comprehension, to interpret the text effectively. The model then integrates the responses from both modalities, ensuring that it can handle the interaction seamlessly, even allowing for real-time audio interrupt interactions where a new audio query can halt the current response generation. This sophisticated interaction is facilitated by the duplex deployment framework, where one model generates responses while another monitors for new queries, ensuring efficient and responsive communication.
What are the specific theoretical and practical benefits that VITA offers compared to existing multimodal models, particularly in terms of performance across different modalities?
VITA offers significant theoretical and practical benefits over existing multimodal models by achieving advanced performance across 4 modalities: video, image, text, and audio. Theoretically, VITA integrates a unified framework that allows for end-to-end processing of these modalities, enhancing its multimodal understanding capabilities. Practically, it demonstrates superior performance in image understanding, outperforming specialized models like LLM Next and closely rivaling proprietary models such as Gemini 1. 5 Pro. In video understanding, while VITA shows a gap compared to video-specialized models, it compensates by supporting a broader range of modalities and prioritizing user interaction capabilities. Additionally, VITA's innovative duplex deployment framework enables real-time audio interrupt interaction and non-awakening interaction, which are largely unexplored in existing open-source models, thus enhancing user experience and interaction efficiency.
How was VITA validated or tested? Describe the datasets used, the experimental design, and the metrics employed to assess its performance across language, audio, and multimodal tasks.
VITA was validated through a comprehensive evaluation across language, audio, and multimodal tasks using various datasets. For language performance, it was tested against the official Mixtral 8x7b Instruct model on 4 datasets: C-Eval, AGI-EVAL, MMLU, and GSM-8K, which cover multiple-choice questions, multidisciplinary QA, and mathematical reasoning tasks in both Chinese and English. In the audio domain, VITA's robustness was assessed using the WinetSpeech dataset, which includes test_net and test_meeting splits, and the LibreSpeech dataset, which evaluates generalization on unseen data. For multimodal capabilities, VITA was evaluated on benchmarks such as Me, OCR Bench, Hallusion Bench, and Video Me, where it demonstrated superior performance in image understanding compared to LLM Next and competitive results in video understanding. The metrics employed included accuracy and performance comparisons against both open-source and proprietary models, highlighting VITA's advancements in multimodal interaction and understanding.
What limitations or drawbacks does VITA present, especially concerning its scalability or effectiveness in real-world applications, and how could these impact its adoption in the field?
VITA, while pioneering in its multimodal capabilities, presents limitations that could hinder its scalability and effectiveness in real-world applications. Firstly, despite its advancements, VITA's performance in video understanding still lags behind specialized models, indicating that it may not fully meet the demands of applications requiring high-level video comprehension. Additionally, the reliance on a duplex deployment framework, which involves 2 models operating simultaneously, could introduce complexity and resource demands that may not be feasible for all users or environments. Furthermore, the model's ability to filter out noisy audio inputs relies on existing voice activity detection (VOD) technologies, which may not be foolproof in diverse acoustic settings, potentially leading to misinterpretations of user queries. These factors could limit VITA's adoption in scenarios where robust performance and resource efficiency are critical.